Hi, my name's Chris Chambers with Meter Group. I'm here today to talk about tough installations of soil moisture sensors. There's an immense variability in soils, ecosystems, and plant canopies across the planet Earth, and sometimes you're just going to find yourself in a situation where it's difficult to install soil moisture sensors. So we're going to talk about some of those situations and some tips to get the best possible installation. And they're tough sometimes because soils have rocks. Not all of them, but some of them. You'll run into clay soils. Some soils have layers of calcium carbonate deposits, and super dry soils can also be really tough to install sensors in. The amount of variability that you can run into kind of means you never know quite what you're going to get. Rocks happen all the time in soils. It can be very variable. Sometimes you just have a few rocks that it's easy to get around. Some rocks are all the way up through the soil profile and can actually define your soil. The main rule in the game of rocky soils is rock beat sensor. You can see here there's what the sensor should look like on the right, and a sensor where I tried to just power right through the rock with the Teros borehole installation tool. The rock one, never try to power through rocks. It's just not going to work out well. When you do run into rocky soils, there are some things that you can do to get the best possible installation. There's frequently a spot. It may not be big, it may not be obvious, so you might need to probe around with your sensor a little bit. If you hit a lot of resistance when you're pushing the sensor in, reposition it. Do not try to force the sensor through, or you're going to wind up with a broken sensor like I showed previously. A trench or pit installation may be better than a borehole. A borehole may not even be possible in some rocky soils, and you might not be able to see where the rocks are if you do dig a borehole and are trying to use an installation tool. So rocky soils may not be the best option for the Teros borehole installation tool. It's probably better to dig a pit or a trench so that you can see the rocks and move the sensor a little bit to the left or the right or up or down so that you can find a spot to poke those prongs in between the rocks. Dry soils can also be challenging. It may be really easy to install in a soil, even a clay soil, if in the springtime, after a good soaking rain or after the snows melt. That same soil later in the season, particularly in areas where you do not get very much summer precipitation, you may not be able to install a sensor in that soil very well. Some soils have layers of calcium carbonate precipitate. Frequently, you can break through a caliche layer. There may be a good spot to install a sensor below or above it. But if you're trying to install right inside it, you may have a hard time. If you have really dry soils, it's going to be really tempting to just give that sensor a smack. Try to push it in through that hard soil. Please do not do that. The electronics in the sensor may be okay. They may not be okay. There are some delicate electronics in there where you do not want to just hit it with a hammer, even a rubber hammer. If you have old sensors laying around, try an old sensor. Use it as a pilot tool. You can make some holes and then get your real sensor with which you want to take measurements in those same holes. And they should fit snugly enough where you don't have any gaps. Or again, you might be able to reposition the sensor and try again. Plan ahead if possible. Spring installations are usually the best, particularly in the northern hemisphere where you get some snowfall or some winter rainfall, and you're starting with some good growing conditions. Here on the Palouse in Pullman, Washington, we have very nice soils. We hardly ever run into rocks. But even with our really nice Palouse silt loams, we don't get precipitation generally through June, July, and August. So by the end of the August, even in really nice soils, it can be difficult to install a soil moisture sensor. So in the case of precipitate layers, if you can, go above or below them because you can usually break through them. If you can't, use a pilot tool, try to make some pilot holes and protect the sensors that are going to take your measurements that way. Frozen soils. I think it's best not to install it all in frozen soils. If you must, treat it much like dry soils. Use pilot tools, pack the hole in as best you can. It's probably going to be chunky and not break down very well. These sensors do not detect ice, only the liquid water. So if you're looking for ice, a dielectric soil moisture sensor may not be the best option for you. And again, if you get a melted period, it's best to install during that time of year. You'll occasionally run into organic soils. Here we have an example of a peat bog in northern North America. These are areas where this soil is literally made of layers of sphagnum moss in various stages of growth and decomposition. Dielectric soil moisture sensors usually work great in these situations, but they probably need a custom calibration. Treating it like a mineral soil is generally not going to give you very good data. So we have, for the Taro sensors, we have a soilless calibration that will work better. And we also have a procedure to do your own calibration to that substrate on our website. So you can take a look at that procedure, make your own relationship between the electrical properties of your soilless media and the water content and get high quality data. Tensiometers will probably work very well in a situation like this, but you might want to avoid solid matrix sensors like the Taros 21 or 22 that might be difficult to get good contact with this type of substrate. If in doubt, these are just a few small instances that you might run into or examples of tough installations, but given the variability in our ecosystems, you'll probably run into something completely new that I've never even seen or know about. If in doubt, get good soil to sensor contact. That's the main rule of installing soil moisture sensors. The second rule to install soil moisture sensors is get good soil to sensor contact. If you do nothing else, that's going to be a major step towards getting good data. And if you get bad contact, that can really impact the quality of your data, no matter how good your sensor is. It's always good to minimize soil disturbance, but not at the cost of poor soil to sensor contact. If you're going to sacrifice one of these three rules, compromise on rule number 3, dig a bigger pit, look around for rocks, and try to get the best possible contact with your sensor in the soil. Thank you so much for your attention. I hope you have an easy field season with no tough soils to install in. Feel free to give us an email at support.environment@metergroup.com if you run into any situations in which you would like to chat with one of our experts.